Today the topic of discussion is in doubly linked list. What we have to understand how to delete a node at mid position, that is other than beginning and end. You want to delete a node which is not at the beginning, which is not at the end, somewhere in middle. Fine. So this is what you have to do to delete a node in somewhere in middle. Fine. So how you will do this? What will be the method of doing this? So but prior to this, what we have understood how to create doubly linked list, and in that we have seen what is the menu program, and after that we have seen how to print element of doubly linked list. Then we have seen how to insert node in doubly linked list, and we have seen three cases, that is insert node at beginning, insert node at mid, that is at any position other than beginning and end, and then insert node at end. Then after that we have seen how to delete a node, how to delete a node from beginning. So we have seen this coding also. Prior to this video we have seen this beginning also. Now my job is to delete a node from middle, that is other than starting and end. So let's see the coding. So the coding, before moving to coding, you know that delete is still have three menus. That is a menu, that is one, if you press one you can delete from beginning, if you press two you can delete from middle, if you press three you can delete from end. What do you want? So my job is to delete from what? Middle. So what I'll do, I'll press 2. I'll press 2. The moment I press 2, switch will have value 2. Then in case 2, I'll jump to case 2, and case 2 I'm calling a function del mid. I'm calling this, I'm calling CALLING, calling this, and you can see the linked list. Currently I have a linked list having four you can say nodes, where head is representing a node having value 4 and tail is representing a node having 7. Fine. Okay, so let's start with delete mid coding. So what I did, I've created two pointer, one temp and one current, and I have initialized this current with head. So and the data type of both the pointer is node1. So what is node1? I have already explained you that when we were creating this doubly linked list, we have created a structure. Name is node. There are three part, one data which is of integer type, two pointer next and previous to keep the address of next node and previous node, and data type of both of them are struct. I've created a variable node1, and what I did, I have type defined this structure. That is, this entire structure is now represented by node 1. By type defining it, it means I have, I have made this node 1 to be the representative of this entire structure. So instead of writing struct node, I'll use only node 1. Fine. So hope you have understood what node 1 is all about. I have created two variable I and position. So I have created one variable I and I have created one variable pose, but position need to be initialized. I have asked user enter the position to delete. So now suppose you have a linked list, and now I'm asking user which position you want to delete. Suppose user said third position, that is you want to delete this third node. So what will happen actually? So the moment I have to delete this third node, what I'll do? So I'll go to the loop. I'll go to the loop and I'll see what is happening. First of all, what I'll do, I'll initialize current with head. So current head, what is there in head? 100. So current will have 100 value. Fine. Okay, then I'll see position is position not, while position not equal to I plus 1. What is position? Position is fixed 3. And what is I plus 1? 1. 1 plus 1 is what? 2. Is 3 not equal to 2? Yes, 3 is not equal to 2. Condition become true. I'll move inside. What I'll do, I'll update current. Current will have current next. What is current next? 200. So current will move from here to 200 node. Fine. Okay. I'll increment I. I will become 2. What I'll do, I'll again check while loop. Is position? Position is fixed 3. Is not equal to I plus 1. What is I now? 2. What is 2 plus 1? 3. Is 3 not equal to 3? Condition become false. 3 is equal to 3. Condition become false. I'll come out of the loop. I'll check if block. Position is equal to I plus 1. What is position? 3. And what is I plus 1? 2 plus 1? 3. Yes. 3 is equal to 3. Condition become true. I'll move inside. Now I will move inside. And what I'll do, I'll initialize temp with current next. What is current next? 300. Fine. So what will happen? Temp will become 300. So temp will come at 300. So if you see the figure, you can see that current is at second node, temp is at third node, the node which needs to be deleted. Fine. Okay. Now what current will ask temp? Current will ask temp to kindly give your next address. So temp will ask why. So current will say because you are going and I'll keep the address of next node of yours, which is 400. Fine. So what actually taking place is, see the example. So this is this I have done. Now I'll do this current next. What is current next? This will have temp next. What is temp next? 400. So here it will come 400. So the moment it will come 400 over here, so this will start pointing node 400 and this link will get broken. Fine. Okay. Now what I'll do, I'll ask temp next. What is temp next 400? What is temp next? See this. Temp next is 400. This means I'm here. Temp next previous, that is 400 previous is this. I'm talking of this. I'm writing and I'm explaining you. Temp next previous. So what is temp? Temp is 300. What is temp next? 300 next, 400. And what is 400 previous? 300. So I'm here. Finally, I'm here. So what am I doing is that I'm putting current at that. What is value of current? 200. So I'm putting 200 over here. So the moment I put 200 over here, this node will start pointing this node and this link will get broken. So now temp is not having any connection neither with 200 node, neither with 400 node. So temp is now isolated. Fine. So temp is now isolated. Fine. Hope you have understood what I was trying to tell you. So temp is now isolated. What I'll do, I'll simply print on the screen deleted element is %d, and this %d will print temp data. What is temp data? 6. So screen will have deleted element will have is 6. I'll feel good. Yes, third node was 6 and 6 I want to delete. Now what I'll do, I'll free temp. The moment I free temp, what is free? Dynamic memory allocation function, which will destroy the memory. So this temp will get destroyed. So the moment temp will get destroyed, what will be the final structure which we are going to get is let me delete all these things, all this rubbish, then you will find the final structure. So the final structure, you will see this temp is now no more there, this 6 is not no more there, head is at 4, tail is at 8, and this 6 has been removed, completely removed. So this was all about how to delete a node somewhere in middle, that is somewhere other than head and tail. So this was delete from the middle.